Okay, welcome back. So here we are about to calculate the 90 percentile confidence interval, right? For a tomato meter rating of 55%. All right. Now, this is on your book is 13.8, right? So you have an example there, and I'm just going to follow the steps on Excel, right? So here, this is basically the formula. So I don't really need this. Let's go to Excel. So this is your formula copied from your book, and you see it's kind of a lot of variables here, and we just have to make sense of it, right? So I created a small table here to identify the variable that I need. So what do I need here? I need the y hat, all right? So that's for 55, and that was already calculated. So this is the 12.726. We did it earlier. Now we need the SXY. SXY is already given to you by the table. So it's right here. That's the standard error. This one, and that's going to be the value. All right. So I'm going to put the values here already. So equal sign, and let's go and select it. Okay, so that is selected already. The y hat, we can do the same thing, equal sign, and we select one of the values, it doesn't matter. Okay, the n, we have the n as well. So the n is going to be number of observation, and that's going to be 7. The h, we're going to try to calculate it. The SSX, we're going to calculate it. And the T alpha over 2. So this is basically the critical value. How can we get the critical value? So the T alpha over 2 is going to be equal sign T distribution that you're going to do the inverse and then 2 tails. And then you're going to put the probability. So since you are doing the 90th percentile, so here you're going to be 1 minus 0.9, which is 0.1. All right. And then comma, degree of freedom is n minus 2 for simple linear regression, and that's going to be 5. All right. So I hope this is clear. So let me repeat it again. For the T dot inverse dot 2 tail, and then you're going to put the probability here. So this is going to be 1 minus alpha. All right. So this is going to be 0.1, comma, and then you're going to put degree of freedom. That's degree of freedom here. That's going to be equal. Well, we don't put equal there. That's degree of freedom is n minus 2. All right. So that's the formulation. Of course, you have to start with the equal sign, right? Okay. So having said that, let's calculate the SSX. So the SSX will require the X values. All right. Once you get the X values, you're going to look for the average. Equal sign, average. Open the parentheses, and you're going to calculate the average of these values. So now I am calculating the SSX, which is this value. All right. So the formula is there, by the way. All right. So I'm just going to follow the formula, which is this one. So it's the sum of xi minus x bar. Whatever I calculate here, 54 is the x bar. I'm going to square them and add them up. So here in this column, I'm going to calculate the difference, the x, which is the xi's, minus x bar, right? Let me put xi's here, minus x bar. close it, and square it. All right, so that's what I'm going to do. So I need to put the formula first. Here, you're going to be equal sign, open a parenthesis, click on the 16 minus the 54. You have to lock it. That's F4. And then close the parentheses, shift 6 and 2. That's the first one. And then you're going to drag it. And that's all the values. All right. Now what I'm going to do, I'm going to do the sum, the symbol sigma. You're going to be the sum, equal sign sum, and select all these values. So this is SSX, equal sign, and select this value. Now there is another value which is, to calculate the h, we need xi minus x bar squared. This is without the sum. And what is the xi? Is 55. So I'm going to add another one here. So value 55. And I need only this value that I see here. All right. So I'm going to copy this formula and paste it over here. And that's going to be 1. So I can add another one here. So this is this formula. Okay, so that's going to be equals to this value here, 1. Now I can calculate the h, and you can see the h here is 1 over n plus that value that we just calculated, xi minus x bar squared divided by the SSX. All right. So let's put it in here, equal sign. So you're going to be parentheses 1 over n, is this one, close the parentheses, plus, open the parentheses again, you're going to be this value, that the xi minus x bar, divided by the SSX, which is this value, and close the parentheses. And that's going to be the value of the h. I think we are ready right now to calculate the confidence interval. So the confidence interval, we're going to have 2 values on it. Let me go back again. So you see the formula here is very similar. So the first formula here and this formula here, they are exactly the same. Only the thing, one is having plus, one having minus. Now this, I'm going to call it the minimum value, and this is going to be called the maximum value, right, for the confidence interval. All right, let's get into the formula. All right, let's start with the minimum value, which is going to be equal sign, that's going to be the y hat, this one, and then it's going to be minus the t value times the syx, this is 7.62, and times the square root sqrt, open the parentheses, of h, and close the parentheses and enter. All right, so we're going to do exactly the same thing for the other side with a plus sign. So you're going to be equal sign, this value plus the t value times the standard deviation times the square root of h, sqrt, and then the h value, this one, and enter. There you go. We get these 2 values. So we're going to plug them in. You want to round to 2 decimal places. Second value should be this one. And again, round to 2 decimal places. Good. All right, so we stop again here and we get back with prediction interval.